Right, we're beginning section 7.3. This section is going to teach us the product rule for radicals, and it's also going to help us see how to simplify a radical into lowest terms. So we're going to start with what is the product rule. So if the nth root of a and the nth root of b are real values, meaning they can actually be computed, and n, the index, is a natural number, then the nth root of a times the nth root of b is equal to the nth root of a times b. So what must be the same about the radicals you're multiplying together in order to use the product rule? You must be taking the same index. So let's try a couple here. So we're going to take the square root of 7 times the square root of 6. You keep that same square root symbol and you multiply the numbers together. So you get the square root of 42. If you take the cube root of 9x times the cube root of 4y, you would multiply. You keep the same cube root and you get 36xy. Here you have the fourth root of 3x, the fourth root of 2x, and the fourth root of 5x. You're going to multiply that together. You keep the same fourth root, and you get 30x to the third. So that's how you use the product rule. Now, there will be, on occasion, radicals wanting to be multiplied together where the indexes aren't the same. So can we use the product rule to multiply the cube root of 7 times the fourth root of 3? The answer is no, because different index. So what do? We go back and remember that we can write a radical also as a fractional power. So we start by saying 7 to the 1/3 power times 3 to the 1/4 power. Then the denominator tells us the root we're taking. So for fractions, we could get a common denominator. So that's our next step. We're going to make 3 and 4 have a common denominator of 12. So 3 goes into 12 4 times, so this is 4/12, and 4 goes into 12 3 times. So now we have the same denominators, which means that we could say that now both of these have the 12th root that could be applied. So we turn them back into roots, so we have the 12th root of 7 to the 4th times the 12th root of 3 to the 3rd. So now we're able to multiply these radicals together because they share the same index. So when we multiply radicals that share the same index, we keep that same index and we multiply together the numbers. So we're going to take 7 to the 4th power times 3 to the 3rd power. We get 64,827. This would be done exactly the same way. If you would like to try it on your own, you can do so. It would follow the exact same steps as this problem. Now the other half of 7.3 is about learning that all radicals need to be in simplest form. So let's review parts of a radical. So the nth root of a, n is the index, and a is the radicand. So there are 4 conditions that must be met for a radical to be in simplest form. Right? First, the radicand has no factor raised to a power greater than or equal to the index. So this is simplified because the inside power is smaller than the outside index. This is not simplified because the inside power is larger than the outside index. So that's rule 1. Rule 2, exponents in the radicand, that would be under here, and the index of the radicand have no common factors. So here 5 and 6 aren't divisible by anything other than 1, but here 4 and 6 are both divisible by 2, so you could not leave that. Third, the radicand has no fraction, so we wouldn't be able to leave that 1/4 underneath there. And the fourth one is no denominator contains a radical. So you couldn't leave the square root of 25 below in that denominator. So we're going to pick up one more rule, and then we're going to learn to simplify radicals. So we're going to talk about the quotient rule. So again, if the nth root of A and the nth root of B are real values, and the index, if n is a natural number, then the nth root of a whole fraction could be split into the nth root of A over the nth root of B. You could apply that nth root to both numerator and denominator. So we're going to start practicing these. So we have the square root of y to the 8th over 16. So we're going to write the square root of y to the 8th over the square root of 16. So we get to assume that all variables represent positive real numbers. So we just have to work these out to simplified form. So right here, this is an index of 2. The easiest way to handle this is to do division. So how many times does 2 go into 8? So that's what I want you to do. I want you to do 8 divided by 2. Well, that would be 4. So we get y to the 4th over the square root of 16 is 4. This one is the 5th root of 1 over x to the 15th. So we're going to take the 5th root of 1 over the 5th root of x to the 15th. When your radicand is 1, it doesn't matter your index. Any index of 1 is always 1. So this is 1. Here we're going to do the same idea. If we ever want to clean this up, we're going to take the inside power divided by the outside root. So we're going to get x to the 3rd. 3 is the cube root of a negative 27/64. So remember, every time you take the odd root of a negative, that negative just immediately comes out. And then you get the cube root of 27 over the cube root of 64. So the negative stays, and you get 3/4. Because remember, cube root is what would you need 3 times to get to 27 and 64. The fourth one, the negative is already on the outside, so it just tags along, and we get the 4th root of 81 over the 4th root of x to the 4th. So the negative is still there. What do we need 4 times to get to 81? That's a 3. And then right here it'd be 4 divided by 4. So you would get 1, so you get 1x out. When you're doing this division, it is the new power on the variable. Now those all that we just did cleaned up completely with no radicals remaining. But sometimes that's not going to be the case. So a radical expression in simplest form does not mean a decimal approximation. The simplest form of a radical expression is in a simplest form and may still contain a radical. Now, to help us with some of the ones going forward, we need to review our squares and our cubes. So here are squares: 4, 9, 16, 25, 36, 49, 64, right? This is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared is 81, 100, right? Cubes, 8, 27, right? 2 cubed, 3 cubed, 4 cubed is 81, 5 cubed is 125, 6 cubed is 216, right? So knowing our cubes is going to help us clean these up. So right here, the square root of 28. You could do it with your calculator and you would get a decimal. That does not mean a simplified answer. A simplified answer will contain some kind of whole number or integer answer plus a radical. So here's what I want to do. If I'm looking at a square root, I want to go look at my square list. And I want to see which of these square numbers is the largest one that divides 28. Well, I would say 7 times 4. Now the square root of 4 I can apply the square root to. So I can get a 2, and then the square root of 7 is left behind. So let's try this one. Cube root of 54. I would now want to look at my cubes list because this is a cube root. And I would just go through this list and I would figure out which of these cubes is the largest one that goes into 54. Well, that is 27. So we get the cube root of 27 times 2. So I can apply the cube root to the 27 and I get a 3, and then the cube root of 2 is left behind. So these are radicals in simplest form. Now this one, every time I see the odd root with a negative underneath, I yank the negative out immediately. So now I have negative cube root 16. So cube root, I want to look at my cube list and want to see which of these cubes divides 16. Well, the only one in my list that goes into 16 is 8. So this is negative cube root of 8 times 2. So then I can take the cube root of 8 and get 2. So I have negative 2 cube root of 2. And now they are simplified. Now we're going to go to some that contain variables also. So 32, I still want to look at my square list and want to figure out the biggest square that divides 32, so that's 16. So this is negative square root of 16 times 2x to the third. So the square root of 16 is 4. So I get negative 4 square root of 2x cubed. Now, I can't leave x cubed because my inside power is bigger than my outside index. This outside index is 2, so remember how to handle that is by division. So you want to take 3 divided by 2. Well, 2 goes into 3 one whole time with a remainder of 1. So the whole value tells you how many x's come out, and the remainder tells you how many are left behind. So this is negative 4x square root of 2x. Next one, fourth root. You're not going to see too many fourth roots, but now we need to think about if there's a number that goes into 32 that is a value that could be multiplied with itself 4 times. So we have negative fourth root. We're going to use 16 times 2x cubed because 16 could be thought of as 2 to the 4th. So negative 2, the fourth root of 16 is 2, fourth root of 2x cubed. So this 2 we got by taking the fourth root of 16. This 2 stays behind and x cubed stays behind. Now I want to check if my inside power is smaller than my outside index, and it is. So I'm finished with this one. 10 is just powers. So to clean this up, I need to divide every single one of these powers by 3. So I need to take 5 divided by 3. So that would be 1 with a remainder of 2. So that means that 1a comes out. I'm going to give myself a little space because I've got some other letters to think about. And that means a squared is left behind. So again, remember, the whole value is how many a's come out, and the remainder is how many are left behind. So we'll do the same with 7. 7 divided by 3. Well, that would be 2, remainder 1. Remember how you check division with multiplication. So 2 times 3 would be 6, plus 1 would get us back to 7. So this is how many b's come out. So we get b squared, and we get a b left behind. Now we're going to do c. So we get 6 divided by 3, which is 2, no remainder. That means that we get c squared, no c's left behind. So here's our answer. A, b squared, c squared, cube root of a squared b. This is already a perfect square, so we get -7. And I'm going to divide each of these powers by my index. So 8 divided by 2 would be m to the 4th, n to the 2nd. No radical remains because everything gets to work with the index of 2. Cube root. I want to think about what cube goes into this number. Remember, I'm immediately going to yank out that negative also. So I get cube root, I'm going to say 125 times 2, a to the 7th, b to the 9th, c to the 14th. So this is 5, so I get -5. I'm going to give myself some space because I've got some letters to deal with, and that 2 is going to be left behind. Now I'm going to do my division. 3 goes into 7 twice, so I'd get an a squared, and I'd have an a left behind because 3 into 7 is twice, remainder 1. 3 into 9 is a whole 3, so I get b to the 3rd. No b's inside because 3 divides into 9 evenly. And then 3 into 14 would be 4, so I get c to the 4th. Okay, and 4 would make 12, so I have 2 left behind. So remember, with these powers, you're going to divide. How many whole times the index goes into the power is the number on the outside letter. The remainder is what's on the inside radicand. This one, I'm going to say 4 times 3, x to the 3rd, y to the 5th. So I'm going to get a 2. I'm going to leave myself a little space, and I'm going to have a 3 behind here. 2 into 3 once with an x out and an x in. 2 into 5 twice with 1 left inside. Fourth root of 16 happened earlier on the other page, so we're going to say 16 times 2, x to the 12th, y to the 13th. So this is 2 times 2 times 2 times 2, so I get a 2 out. This 2 is left behind. Now I'm going to divide these powers by 4. 4 into 12 is exactly 3. 4 into 13 is 3 also, but 1 remainder, so 1 left behind. Right? This one, 30. 30 is underneath the square root symbol, so I'd want to look at my square list. There is no square that goes into 30. What that means is 30 does not get to come out, and no part of 30 gets to come out. So now I got to work with my powers. 2 into 2 once, so I get an A. 2 into 7 would be 3 with 1 left behind. Now finishing up this section, simplifying radicals, use or lesser indices, here's what I want to do. I can't take the 6th root of 49, but I can think about this as 7 squared, right? Which I then could think about in fractional form as 2/6, because remember the index represents the denominator. And then I could reduce that to 1/3, and then I can get back to a simplified radical, cube root of 7. You also right here could have just divided these by 2 and gotten right to that answer. This one, x to the 2/4, which is x to the 1/2, which is the square root of x. So when it says simplifying radicals using lesser indices, this means a smaller index. It means you need to work to a smaller index.